Hey guys, welcome back to another episode of Simulos. Today is going to be an absolutely fantastic day. I'm like 92.5% sure, that's pretty sure. I could be more sure. I'm sure I could be more sure. But, hey, we're as sure as we can be. So let's see, what are we doing today? Well, today we are continuing our gift wrapping algorithm. Yesterday we got pretty far. I'm pretty happy with how far we got. Today we're going to actually add in some visualization and stuff like that, hopefully getting gift wrapping basically done. Now, here's the thing. I have decided that I want to do one more algorithm before the video that I want to get out this weekend. And the video will be on basically gift wrapping. I have an idea of how I want to get it done. And I'm looking at the script right now, and I think it's going to be quite good. I've written out the part that has to do with the actual gift wrapping algorithm, which is what we've done so far. However, there is another algorithm that oh my gosh, I have to show you guys. It's ridiculous. So the name of the algorithm is... one second. The ultimate planar convex hull algorithm. This is actually the name of the algorithm. The paper has a question mark in it, but it's come on. The ultimate planar convex hull algorithm. I'm like, dude, yeah, we of course have to do this. There's no other way. I mean, we just have to. It says it's the ultimate planar convex hull algorithm. We got to do it. Now, nowadays, I think there's one other algorithm that people use instead, and that, I believe, is the chance algorithm, because the chance algorithm is a little bit easier to use. So, in essence, maybe this isn't the ultimate planar convex hull algorithm, but instead, the semi-ultimate planar convex hull algorithm, or something like that. It's, I'm really looking forward to this one, guys, because, yeah, I don't know, I just am. So I'm going to look into this today, probably after work today, and hopefully we'll be able to get it figured out by tomorrow, and we'll be able to code it up tomorrow. Today what we're going to do is finish up the gift wrapping algorithm that we have today, that we worked on yesterday, and we'll kind of continue from there. Hey, Deadglism, thanks for coming in. So, what are we going to do? First, let's open up a terminal and start working with Zernal. Okay, so... this is either going to be really good or really bad. I don't know, this video, I'm going to try to not make Christmassy themed. I actually kind of like themed videos. I think they're kind of nice, but at the same time, my channel's not big enough to really warrant themed videos. So I'm just going to try to keep it general, and I'm just going to be like, hey, I want to get you guys a present. And the present I give them is a random distribution of points. Okay, so let's go ahead and get started. We're going to talk about gift wrapping, also known as the Jarvis March. I guess Jarvis was the guy who came up with it. I don't know why he's helping out with gift wrapping. Maybe it's for Iron Man or something like that. I don't know. Anyway, point is, we have gift wrapping, Jarvis March. Here's the idea. We have a random distribution of points. I'm just drawing points at as random as I can possibly make them. And the idea is that what we want is the outside, the convex... Oh, sorry. We want something called the convex hull. Now, the convex hull is the shape that these objects make. So the idea is we start with the leftmost point. Then we search, okay? We search to find the point that basically gives us the biggest angle, if that makes sense. And we find this one. Then we find the next one, which gives us the biggest angle. And the next one, which gives us the biggest angle. And the next one, and the next one. So on and so forth. Until eventually, we have traced out the outline of all these points. And the outline of all these points gives us the convex hull. And that's what we do. We outline all of these guys, and the amount of, I suppose, red ink that we used here is the amount of gift wrap we needed. So red equals amount of gift wrap. And we want to minimize the amount of red. So we want to minimize the amount of gift wrap. And that's why we're using the convex hull algorithm to begin with. Because in the end, the amount of gift wrap that we need is basically related to the exterior shape of the object, and the exterior shape of the object is basically like a random distribution of points or something like that. So this is kind of what we're going with. It's an oddly oddly shaped package where we have a whole bunch of random points, and these random points are kind of distributed in space in some way. That's what we're working with here. It's not particularly complicated, I don't think. This is actually the easiest of all of the convex hull algorithms, and to be fair, is also the least efficient. So it's just the one that happens to be called the gift wrapping algorithm. In fact, if you Google, one second, gift wrapping algorithm, this will come up on Wikipedia. So let me very quickly show you that. So here we are on Google. So gift wrapping algorithm. And here it is, Wikipedia, gift wrapping algorithm. Yep, and so that's the algorithm right here. It's super simple. Like, literally, it's just taking the left point and then continually checking, to see how, checking the angle between all the different points, and then just going from there. It's relatively straightforward, so I don't see any reason to go any further into it. But of course, if you have any questions, comments, concerns, let me know, and I'll totally address those as soon as I see them in chat. Outside of that, let me think. What is my streaming schedule for the next week or so? So, as you guys know, Christmas is coming up. It is, let me see, today is the 14th my time? No. 15th my time. One second. 15th my time. So Christmas is in 10 days. I don't really intend to take any time off for Christmas in terms of streaming, or really in terms of work, because Christmas week is a weekend. So let me think. Here's what I'm going to do. Over this weekend, I will be streaming if we cannot get the ultimate convex hull planar algorithm working. I will totally be streaming this weekend so that we can get that done. And I'll try to get a video out this weekend. If not, it will be during the upcoming week. It shouldn't be so bad. I think I have that one set. Now, as far as what we're going to do next week, I have not yet decided what we're going to do next week. So once we get this done, I'll try to make a video on that. But I haven't quite figured out what to do next week for the next simulation. So if you have ideas, let me know. It's got to be something quick and easy, though. So I think one day I might just go through and do the Merlin Twister. One thing that I really want to go through is the Blum Blum Shub algorithm. Blum Blum Shub. And that's because it just has a funny name, and I really want to go through it. It's just like Blum Blum Shub. Yeah, of course. Everyone knows the Blum Blum Shub algorithm. I think it's going to be fun. But yeah, that's about it. So I kind of want to try a whole bunch of different algorithms out just for fun. So one thing I want to try out is a Mercine Twister, which is a random number generator. And then I also want to try this one out because it's another random number generator. Mercine Twister is, of course, faster because it's, optimized and used all the time. But the Blum Blum Shub, I think, beats the Mercine Twister in naming. Yeah, I think the Blum Blum Shub has a better name than the Mercine Twister. Okay, anyway, I'm going to get a quick sip of water. And of course, if you guys have any questions, comments, concerns, or ideas for future simulations, let me know in the chat, and I will totally address them as soon as possible. So one more thing I want to point out. Let me see. What was I going to point out? Oh, yes. I am now pretty much not sick anymore. So as of the past few days, I've been kind of sick when I'm streaming, but I don't think I am today. Is today Wednesday or Thursday? It is Thursday. Crap. Okay, that's okay. It's Thursday, but yeah, that's fine. That's fine. Plenty of time. So let's go ahead and CD into projects. Simuleos. Is the Julia difficult? I am not using Julia for this one in particular, but Julia is not a difficult language. Let me think. Why would you have... I'm not using Julia for this language, or for this particular project. But if you want, I've done many other projects in Julia up to this point, and I would say that Julia is relatively straightforward to look for. Hey, good news, it's Wednesday here. Yeah, but the issue is that even if it's Wednesday there, I still have a whole bunch of stuff to do on Thursday, which is today, which is kind of why I was a little bit annoyed with that, but that's okay. So if we can get the visualizations of the Jarvis March done today, and we can figure out the ultimate planar convex hull algorithm tonight, then tomorrow we can get that one written, and we can, let's see, what do I want to do? We can get that visualization done on Saturday morning, which should then allow us to get the video out that night, I think, or the next day. Well, actually, my weekend's like packed. Oh my gosh, my weekend's packed. Oh my gosh. Yeah, so anyway, Black Sea, if you have direct questions on how to use Julia, feel free to let me know, because again, I use it quite frequently. So what I'm going to do here, let me see, what am I looking for? I'm looking for gift wrapping. There we go. And let's go and do the same thing over here, CD Projects, Simulaos, and gift wrapping. Okay, so as you can see here, we have basically jarvis.cpp. It runs. I don't know if it's actually working or not. We're going to have to do some test cases to make sure it works, and that's what we're going to spend the first little bit on. So let's go ahead and create a quick test function for our angle finder, as we said before. So let's go into vi gift wrapping. Jarvis.cp. And let me just create a quick test for the angle. Now I could read in C assert, but for now I think we're just gonna output it. Sorry about the yawn, guys. So let me do a quick function in here. Function to test the angle. Function. So it's gonna be let's see, void and test angle, something like this. This should work. Okay, so what are we gonna do? We don't really have to read in anything, I don't think. I think we're good to go from here. So let me yank to yank, and pop down to the bottom, and paste it. Oh, oops. That's okay, I guess. So let's do void test angle. Okay. So what do we need to do? Let's go ahead and first initialize the 3 points. And for the record, I'm just going to make a 90-degree angle, just to make this simple. And the 90-degree angle is going to be angled, I don't know, we'll just angle it up. So what are the 3 points going to be? Well, let's do position. And we're going to say they're going to be 3 points. How about, we can't be negative in this case. So let's just do 0, 0. Let's say A equals position of, and I don't think I put in an initializer, so let's just say position A, B, C. We're going to say A dot X is going to be equal to 0. A dot Y is going to be equal to 0. Yank to yank. Paste, paste. Okay. So now we have A dot X and A dot Y, which I think I just screwed up, but that's okay. RY. RX. Then we're going to say B. And what's the next one? It's going to be C. Okay. So now we have A, B, and C. I'm going to put an extra line in here and there. Now, what do I want to do? I want to say A dot X, or B dot X is going to be equal to 0 and then 1 in the Y direction. And then this one's going to be 1, 1. Okay, so basically the idea here is we've drawn a 90-degree angle there, and now I just want to find the angle between A, B, and C. Just making sure this is how we do it. 1 second. Where is our angle function? Up here. So it should be, yep, it should be 3 positions, and we're just going to say angle between A, B, and C. Okay, so let's pop down here, and let's say angle, double angle is going to be equal to angle between A, B, and C. And let's just call it check angle. And now let's do std cout check angle. Now in our main function, what we're going to do is we're going to go ahead and put in test angle just to make sure it works. So let's go ahead and comment all these guys out for now. 1 second. And let's do a quick test angle. So test angle. Okay, so now let's do a G++. BC was not declared. Of course it wasn't. 1 second. Okay, good. I'm going to run a.out. I don't think I've run a.out yet. And it's not a number. Fantastic. Great. Awesome. We're getting there, guys. So let me see. What would the issue be then? Not actually sure. So let's take a look at what we have here. Where is our angle guy? Here it is. So distance between AB, BC, A cosine of A times A. Maybe this ends up being negative. Let me see. If it's negative, let me see. Where did I get this from anyway to begin with? I have to think real quick. Oh, sorry about that. I accidentally hit the microphone. Okay, one second. I have to find this. Oh my gosh, my notebook. This is why I don't use notebooks like this. Crap. Oh my gosh. I should use my regular lab notebook, but I didn't have it at the time. Okay. So, let me see. I said a squared minus b squared minus c squared is over 2ac. Okay, that's fine. And what did I put down here? It's a squared. But I think actually I want c squared. Let me do rc minus b minus a. ra. Let me think here. I said a squared equals, okay, so a squared, because I was looking for the angle between b and c. What am I looking for here? I'm looking for the angle between a and c. So actually it's going to be b squared. Sorry about that. Let's just go ahead and do it this way. B squared minus c times c. Okay, let's try this one. G plus plus. A dot out. Okay, this is 1.508, which my guess is going to be, this is going to be 3 pi over 2. Wait. No, wait, that's half pi. 3.14. One second, let me open up Julia real quick and multiply this. So 1.508 times 2, 3.14159. Yeah, that's about right. 3.1416. Okay, so Control D from there. Clear here. Okay, so then the question is, why is it half pi? It should be, wait, is that right? Pi over 2. Oh, that is right. It's pi over 2. That's exactly what I wanted. 90 degrees. Fantastic. We got it. Because it's just in radians, so we're good. Okay, good. So that test worked. So now what do we want to do? We have the test angle. Now I guess we can go ahead and try the gift wrap. Just to kind of make sure it runs. And then we'll go ahead and get started on the visualization. And I think we'll be able to finish everything up by the end of today. Pretty sure of it. So let's go ahead and remove the test angle function from here. I'm fairly confident that is working. So we're going to remove this. Remove this. And let me see. What do we have here? We have these for the hole. So let's go ahead and remove the C-outs here. Okay, good. And of course, guys, if you have any questions, comments, concerns, let me know. I will totally try to address those questions as soon as I see them in chat. We just had a segmentation fault, which is fantastic. So let me go ahead and run this with a, how about a -G? And then we're going to run GDB, Jarvis, or a.out. There we go. So let's go ahead and run it, and let's run a backtrace at 101. Okay, so it says while distribution, distance between the current hole, okay, which is a position, which has not yet been defined. That would be why it's an issue. Okay, yep, so that's the issue. So I guess what we're going to do is we're going to define current hole at, let me see. Previous hole is equal to 0.0. The parameter dot hole. I guess what we can do is we can set current hole equal to previous hole for now. Yeah, I guess we can do that. Yeah, we'll set that equal to 0, 0 for now. So let's do current hole. Control D, yes. Now let's run the last G++. Okay, now let's run a.out. Okay, we still got a segmentation fault. I thought that was the issue. So let's pop over here and let's do GDB a.out. Let's run that again. Run the last backtrace. It's at 102 now. Oh, I guess that's the same line. So distance between current hole and parameter hole of 0. Is that because we're not initializing parameter hole of 0? Let me see. Where do we have the init function? The init function is going to be up here. So let's just go ahead and check something real quick. Let's do print. Actually, what is it? Info locals. Okay, so we have current hole, previous hole, next hole. What do I have? Do I not have a par? Final angle and temp. I should have a parameter par that's being read in. Let me just... Why do I not have par? Kernel, threshold, angle, temp. 1 second. Let me see, how are we doing gift wrap? We do gift wrap after init. So we already initialized it. Okay, let me just put a quick cout in here, and let's see what happens. So we have this. Let me just do std cout, and I want to do par dot hole 0. Okay, and line. Now we're going to do control D, yes. Run the last G++. Okay, par dot hole 0. That's because it is a position. Okay, so let's just run dot x, and we're gonna then do tab and par dot hole of 0 dot y. And I bet you I know what the issue is. So let's do g++, a dot out, and now let's run gdb. Let's run that. Run the last backtrace. It's probably going to be at 102 again, but 102 in this case, 102 is going to be the scout. So the issue is that we don't initialize the first value in par.hole. So that's the issue. So let's go ahead and initialize that then. Let's see, what do we have here? We have sort, return par. Okay, find the leftmost point. So we found the leftmost point. Oh, I see what we did. Okay. So we found the leftmost point. We sorted them. Let me think. I guess we don't have to sort them in this way. Let me see. Let me do the following. So we have these positions, which are randomly generated, right? And we want to find the far left point, right? So what we're going to do is we're going to say, can I do this? Let's say, what do I want to do? I guess it's going to be an std vector of positions. And it's going to be temp. It's going to be equal to sort. Yeah, that'll have to do. Okay, so it'll be sort this. Okay. Now what I want to do is I want to say, where are we? Par.hole of 0. How about par.hole.pushback? And now I'm going to say temp of 0. So now let's try Control D. Yes. And let's run the last G++. std sort void. Okay, that's what I thought. So here's what we're going to do. We're going to go up here. And instead of saying par.points, we're actually going to create this temp, and we're going to say it's equal to par.points. And then we're going to pop down here. And we're going to sort. Instead of par.points, we're going to sort temp. Now, this isn't the fastest way to do it, I know. But, you know, it's kind of, we're just checking out to see if this algorithm works. We can make this more efficient later. Okay. G++. Okay, that seemed to work. A dot out. It seems to be doing something. I don't really know exactly what it's doing, but it's definitely doing something. And that's nice. Yeah, I don't know what it's doing. I think we're stuck in an infinite while loop. Yeah, I'm fairly certain we are. Yep. Yep, I'm fairly certain we are. So let's go ahead and Control C here. Now, what do we want to do next? Well, what I want to do is I want to figure out why we're stuck in an infinite loop. So let's see here. If angle temp is less than final angle, so let me think. Last time we had a 90-degree angle. So because it's always going to be the internal angle, I think I want if angle temp is greater than. And let's do G++. Hit it out. Okay, this one is also an infinite loop, which is good. This is good. It's nice. So let's go ahead and Control C. Now, what am I couting here? I'm couting the first hole, which is surprisingly, oh, it's leftmost. Yep, it's surprisingly fine. So let's go ahead and see out the eyes, and let's see what we got here. So what I want to do is see out a couple different guys. So let me do std, see out I, and I want to do tab par.hole of I. And then what do I want? Let's do... Oh, do I do an I++? I don't do an I++. So let me just do an I++ real quick, down here. I++. Pop over here, and let's do a new tab. And par.whole. 1 second. Of I dot y. New line. And I need to do a dot x. Oh my gosh, it's a new line. I'm gonna pop this down to the next line. G++. Edit it out. Okay, so Control C. This tells us a couple different things. One, okay, so the X direction is always going to be, okay, well this is interesting. Y is somehow 1.4 times 10 to the 287th. Which would be fine, except for the fact that we're initializing all the points between 0 and 1. So that's obviously wrong. And x is at 0, basically. Which is incredibly unlikely. So let me see, power points of j. Why would we constantly be pushing back this value? Let me try it again. Oh, these are both negative. Is this just... Why is this point so close to 0? I'm not actually sure why this point is so close to 0. It just is. So let's go ahead and get some visualizations done here, and let's see what we can do from there. So, as you guys know, we've been working on some sort of, kind of visualization library. Let me do an ls ... Let me see, what do we have here? So when was the last time we used the visualization library? We used it in Viral Video, definitely. So let me just cd back into the Viral Video, and let me see what this one looks like. Actually, let me just cp the makefile over here. So cp, Viral Video, makefile, and let's put it here. So let's open up the makefile, and let's see what it looks like. So we have, yep, so it looks like we have the Cairo visualization.h and everything in here. So we should be able to use all those functions just fine. Now let me see, what do I have here? Instead of the bins being Viral Video, let's change the bins to be, what do I want it to be? I want it to be Jarvis, and objects is going to be, I guess, Cairo visualization.o. I don't think I need an h file for this one. Depends, just the Cairo visualization.h. And let me see, what do we have here? ./Viral Video. Let's go ahead and change this to ./Jarvis. Okay, and what do I want here? I want, let me see, visualization, Cairo visualization.cpp. That seems good to me. But what I want to do is, oh, I guess this is okay. Where's Jarvis.cpp? 1 second. I know I need to read in a .cpp file. Where is that? Make. Undefined reference to make. Yeah, of course. Let me take a look at the previous make file. What is it going to be? It's going to be, what am I looking at here? I'm looking for Viral Video make file. Where's the CPP file? Huh. ViralVideo.o. Well, I'm actually not sure how this even works without any CPP files to call on. I always get screwed up with make files, like literally every time I use them, but that's okay. So what do we do here? Bins, objects. Let me see if I can have another CPP file real quick. So let me go into VI, And let's see, what do we have here? We have a whole bunch of things that use makefiles, like literally everything. So let's do color quantization, and let's do makefile. Yeah, okay, I'm doing the same thing here. So is a common thing apparently. Let me see. My chat is super quiet today, and I feel really bad about that. But that's okay. It's fine. So let me see, what do we have here? CXX, CXS flags, undefined reference to main, but I definitely have a main in the Jarvis file. Color quantization.o, vector.h. Maybe what I need to do, let me go back into these files, let me see something. So let's cd back, let's just open up, I don't know, viral video, and viral video, I think there's a .cpp. Okay, this seems fine. Main is there. That's fine. So let me see. Via makefile. What do we have here? CXX is G++, not a big deal. Now what do we do? Cairo flags, Jarvis. Right, we have Jarvis, don't we? It is jarvis.cpp, yep. Okay, Cairo visualization.o. I think that's the only object we'll need. I guess we can put the Jarvis header files. Like we can have a header file for Jarvis and jarvis.h if we wanted. But do we need that? Let me take a look. Jarvis.cpp. No, we don't have enough functions to warrant a header file at this point. Okay, so what do we have here? I'm actually not sure at all why this isn't making. But this is because I have a real big trouble, or I have a lot of trouble reading any type of, one second, any type of makefile. I always have trouble with this. So let me see. Let's see, so we have all the CPP. Bins. It's gonna be Jarvis. Let me just take a look at some of the previous guys here. So let me go into backup directory. ls cd into geometrical optics. ls, what do we have here? vi makefile. And let's see, what do we have here? Geometrical.o. I guess we go into vi geometrical.cpp. Let me see here. So yeah, everything here has a header file. Let's just go ahead and see what happens if we create a jarvis.h. So let's go ahead and do vi jarvis.h. And let's do it. So let's create the makefile. It's going to be like this. Jarvis.h. And let's just do it. So it's going to be header file. Header file for jarvis.cpp. And let's just go ahead and put all the functions in it. Should be okay. Something like this. So now we have to do an, what is it, if and def? Jarvis H. I guess define. Oh, I think it has to be up here. Define Jarvis H. And then I want to pop down here and I want to say end if. Okay, so now I want to open up over here, vi jarvis. I'm in the wrong directory. Let me open up a header file where I'm here, geometrical.h. If and def is first. Dagnabbit. I always get those mixed up. Okay, good. Let's go ahead and write and quit. Quit. cd back directory into gift wrapping. And let's open up vi jarvis.cpp. So now what we're going to do is we're just going to take all of this guy and we're going to pop them into here. And that should be everything we need. Good. So let's pop over here. Let's go and remove everything here, and let's just include jarvis.h. Yep, that should be okay. Run quit. Make undefined reference to main. Let me see. output Jarvis, Cairo visualization.o. In function start, let's go into the makefile, and let's add in jarvis.o and jarvis.h. Okay, that one seemed to work just fine. So I guess whatever, it's fine. We'll just have a header file for this. Not the biggest deal in the world. Seems to run okay, so that is perfectly fine. Again, I need to look at that makefile again and figure out exactly what's happening, but that's perfectly fine. So let me go ahead and go into back directory, into visualization. And then I want to go into, I think it's Cairo visualization. Yeah, Cairo. And Cairo visualization.h. Let's see what functions we have. So we have frame. Okay, so let's go ahead and initialize all the frame stuff and all that kind of stuff. So I know this is a very particular way to initialize it, but let's see, what do we have here? Draw human stuff, grow circle, animate line, draw layers. Yeah, so we have everything we need. So I guess we're just going to draw all the points with this grow circle command, and we'll kind of go from there. So let me just go back a directory into the viral video stuff, and let me see what happens if we go into viralvideo.cpp. And let's see, what do we have here? I guess what we want to do is visualize moving network. Here we are here. And let's just go ahead and define all this guy's stuff, just to make sure we have it. So let's go into vi jarvis.cpp. And what do we have here? So we have the main function here. Let's go ahead and initialize visualization stuff. Now this means we're going to have to modify some things, but this is okay. So what do we want? So we need to initialize all this kind of stuff up here. So frame anim, current frame, create background. At least all this stuff needs to be initialized. Basically the idea here is that we are, there we are, creating an animation frame. And then we're basically working from there. So in each of these frames, we have basically a single picture, and these pictures will be wrapped together into an animation at the end. So that's why at the end we have this anim.draw frames. There we are. Semicolon. Okay, what else do we have here? I think this is all we need. So now what I want to do is go into each of these functions and add in an additional dependency here. So let's go ahead and right quit and vi jarvis.h. Okay. So now what I need to do for dist, angle, nope, none of these things. What I need is for gift wrap, I need to read in frame ampersand anim. And let's go down here and let's do that for gift wrap. Okay, so we're going to do frame ampersand anim. Pop over here. Let's make it just to make sure. Okay, frame has not been declared. This is probably because I haven't included the appropriate directory. So let me go in here and let's include that. So we're going to include jarvis.h. And let's go down here and let's also include visualization, Cairo. Oh, what did I call it? Visualization, Cairo, Cairoviz. Okay. Make. Of course, too few arguments in gift wrap. Anim. Let me see. Error frame has not been declared. Okay, 1 second. Sorry about that. I know I said that I was getting a little bit better, but I am not exactly best yet. So let's go ahead and right quit. And actually, let me go ahead and yank this line, or just take this line and put it in jarvis.h. It'll make things a little bit easier, I guess. I know that's not common practice, but for now, we're kind of just testing with things. So let me go ahead and put it here. dd, right quit, make, and this one makes just fine. I don't know what we're currently outputting. Oh, I know what we're currently outputting. That's because it's actually an infinite loop. So that's something we need to look into. Okay. So what are we going to do then? We have everything set. So I guess now in the gift wrapping function, we're going to go ahead and initialize all the points. So let's go ahead and draw all the points to start. First, we need to draw the random distribution of points. Okay. So let's get that done, and then we'll figure out what's going on with this while loop after that. So what are we going to do? I guess what we need to do is... Yeah, I guess what we need to do is go through all of the random points. So let's go through for int I equals 0, I less than par dot points. Then we do I plus plus. There we are there. Then we go through all the points, and basically what we need to do is grow a circle at each of these points. So what we need to do is get the actual positions of each of these points, and then we just need to call the grow circle function. And that should be about it. So let's pop down here. And let's do... Let me see. Let's go in here. And let's do VI. What do I want here? I guess we're going to go back a directory to visualization. Cairo visualization dot h. And let's go into grow circle. Okay, let's see, what do we have here? We have frame atom. So let's go ahead and read each of these guys in. So we're going to do grow circle. Now here's the thing. We use a vector for each of these guys instead of position. So what I need to do is basically change all my positions to vectors, and that should be okay. So we're going to do grow circle. And what I want to do is enum time, which I guess I'll just put down as 1 for now. Vector origin. Let's actually make this 0.5. So the origin is going to be at, we should probably define the origin. And then what do I want? I want double radius. Yep. So let's see, the radius we have, let's just set the radius to 10. So the origin we're going to set to, let's say, I don't know, I'll just call it Ori again. And then what do I want to say? I want to say radius, we're going to set to 10. And then double weight, that's going to be, what's the weight going to be for grow circle? Let me take a look at that. So VI, visualization, Cairo visualization dot CPP, and let's do grow circle. And let's see, what do we have here? Grow circle here, and I want to find out what the weight does. Temp weight, okay, that's fine. Weight less than 0.5. Adding a color ramp. Oh, okay, so this gives it a color ramp. Let's set the weight to 1. Just so they're all the same color. We can obviously change the color as we go along. In fact, we could do that. Let's just say, I think the weight has to be between 0 and 1. Yeah, so the weight has to be between 0 and 1. So let's just change this to, I don't know, let's make it so it is, double of I divided by the max I, which is going to be par dot points. Yeah, so this will range between 0 and 1. That should be okay, I think. Okay, so now what we need to do is change all of the positions to vectors. So let's pop up here real quick. And let me see something real quick. So I think I need to read in the vector.h file or something like this. So let me go ahead and right quit. And let me see, but it seems like vectors were already defined. So let me just see what happens if I go in here and I just define a very quick vector or something like that. Oh, can I set position equal to vector? I wonder. Let's go into vi jarvis.h. Let me see what happens if we can do that. So we're gonna say struct position. What happens if I just do ddd? I don't think I can, but let's try. Equals vec. Make. Yeah, I figured I couldn't, but I wanted to give it a shot anyway. Let me see, what's the actual error though? Let me see. Jarvis.h. Yeah, okay, that's fine. So what I need to do then is I need to go into Jarvis.h, and I need to basically search for all of the positions and change them to vectors. So let's do it. So let's look for all the positions. So I'm going to search and replace position for vector and see. Purpose, so that's going to be a no. Yes. 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 Return to continue. Oh, I guess we're gonna have to do it again. Is there a way to, let me try something else. Let me do, S position vector, CG. Am I allowed to do this? Nope. Yes, yes, yes. And there we go. Okay, let's do the same thing over here. So we're gonna change all these guys. And let me go up here and let me remove this vec struct, because that's unnecessary. So now we're gonna do the same thing over here. So it's gonna be S position vector CG. Nope. Nope. Yep. Nope. Nope. Yes. 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 Okay, I think that's it. So let's see what happens if we make. It of course breaks, but that's okay. This is breaking because, let's pop up here to the top. Actually, let me just go ahead and clear a couple times. So let me do Control L, 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 and now let's do make one more time. Holy crap, am I online? Like, 1 second. Okay, that's fine. Am I getting chat, but I'm just missing it? I mean, okay, let me see something real quick. Pop over here, open up this guy. Okay, that's fine. No, that's fine. Just want to check. Okay, so let me see if we can find the top of this error real quick. So it's all the way up here. No match for operator. And let's see, par.points. Par.points. Oh, I did something really stupid up here. Let me go to 74. This is actually, I need to put a size. And let's change this to a size T, just because, you know, I like size T's. They're nice. Now, grow circle. I need to go ahead and create the origin. So what we're going to say is we're going to say origin. Testing chat as well. Okay, fair enough. I don't know. I think it's weird. So let me go up here and let's create a vector origin. And we're going to say origin.x is going to be equal to, and what do I want here? I guess we're going to say par.points of i.x. And then we're going to multiply this by the animation.frame. What am I going to do? Resolution x. And then we're going to do the same for y. So origin.y. Par.points y here and y there. Okay, so I think this should make. Let's see what happens. Let's go ahead and clear here. And let's make it. Okay, no match for operator. Less than. And that's because this needs to be par.points dot size again. Make. Okay, and this one seems to make. We of course have the infinite loop, but that's okay. That's okay. So let's go ahead and comment out that infinite loop, and let's just see if we can actually get this guy to draw appropriately. So what do we want here? Animation, grow circle. Oh, you know what I need to do? Let's go ahead and comment out this loop. Let's pop down here. And let's just see if we can get all these circles to be grown in the right spot. So let's make that. Okay. Seems like we're generating a bunch of images. I don't know how many images. This seems like more images than I thought I was going to draw. Yeah, that was a lot more images than I thought. So let me go into Mirage. And then I want to go to temp image 0 whatever .png. Scroll down. Oh, here's one circle. Oh, look at that. We have all the circles being drawn. Wow, that's quite cool. And look, they're slowly turning red. Oh, I ran out of freaking... Okay, 1 second. What do I want to do then? Grow circle? Let's change this to 0.1. And now let's try it one more time. Make. I'm generating too many images, but that's okay. This is kind of neat. So what we're going to have to do is give it a little bit of a border so that the points are actually generated, you know, within a space. So let's go into Mirage Temp, scroll down. Look at that. All the points are being generated. Oh, that's super cool. Oh, man. I like that. Okay. So let's go ahead and give this guy a little bit of a border so that we are not at the edge of the screen. But yeah, this is looking okay. So we do that. Then all we have to do is once all the points are generated, we just have to draw the appropriate lines, you know, and then we're good to go from there. But actually, this is okay. Let's change this to 0.5. Let's make it one more time, just because I kind of want the points to be smaller. When we make a bigger resolution image, we're going to have to play with these variables anyway. And I'm going to make a quick note of that at the top real quick. So let's make a note of that. So test angle function has already been done. So let's go ahead and remove that one. It's going to be a D, oh, sorry about that, D $sign. And we're going to say fixed gift wrapping syntax. Yeah, that's fair enough. I'm probably not actually going to do that, but it's in the notes. So if anyone looks at this code later, they're going to be like, oh, okay, the gift wrapping syntax is bad, but you know what? He had plans to fix it because it was up there in the notes, right? So that's okay. When scaling visualization, what do I want to do? I want to say when scaling visualization, change parameters. I'll say fiddle with parameters. Okay. Guys, I will be right back. I'm still a little bit sick. Gotta blow my nose real quick. Sorry about that. Okay, back. Sorry about that. Okay, so I think everything else is set. So now, what do we need to do? We need to get this while loop to not run infinitely. So what am I going to do about that? Well, we have two positions. We have an animate line function. Let me go through and let's just go ahead and set the time at which each of these guys draw to be like right at 0. In fact, let's make it exactly 0 for now. And we'll see what happens. So let me do that. Here, let's see what happens if we change this to 0 exactly. Let's go here and let's do make. Give it a second to make. Oh, I see what I was outputting. I was outputting. Yeah, okay, so let's do Mirage Temp. Go down one. And, oh, they're super small. Yeah, those are way smaller than I wanted them to be. So let's go here and let's change this to, let's just change this to 1/60. Actually, 1/animation.fps. Go here, make, give it a second to make the animation. Okay, well that wasn't exactly what I was anticipating happening. I think this is going to be the same issue as we had before. Mirage Temp, that they're all super small. Yeah, well, there they are. But why are you all super small? Okay, I don't know why they're so small. They seem to be exactly 1 pixel in size, but that shouldn't be the case. What happens if I... Oh, that wasn't what I meant to do. Let me just go back to changing this to 0.5 again. And let me see what happens if we write this and we do make. What did I do? Did I break it? How did I break it? 1/animation.fps. Oh, you know, I bet you what? Yeah. Yep, that's exactly what happened. Yep. These animation FPS was... Why are these so small? Holy crap. Like, what happened there? What did we do to make them small again? Oh, I know what I did. This needs to be a 5. Or a 1, or something like that. That was my issue. So now we're going to do, let's do 1/double of animation.fps. Thanks, Dr. Kegel. So we're going to pop this down to the next line. Oh, what am I doing? That wasn't what I meant to do. I don't know exactly what happened there, but that's okay. 1 divided by double of animation.fps. Whatever. Let's make that. Give it a second to do its thing. And this means that we're going to be generating 1 dot per second. Yeah, we could do that too. Mirage Temp. Okay, there we go. This doesn't look bad. I think it looks quite nice. There we go. We have all the points being generated. That's fine. So now all we have to do is give them an appropriate X position. So what are we going to do here? What I'm going to do is I'm going to get a quick sip of water. That's what I'm going to do. And then we're going to give these guys a little bit of a smushioning. Smushioning is the technical jargon here. I understand if you wouldn't know it. It's only used in very select groups, mainly those who are very well versed in Simulanese. Yep, that's a language now. Animation resolution.x. So here's what I want to do. I want to say, let's go up here and let's say X range. So what do I want to do? I want to say X range. Let's do double X range is equal to animation dot resolution X times 0. Unless we don't really need it that big, or we don't really need to smush them that much. So let's say 0.9. We do the same for Y. So let's change this to an RY and RY right here. Okay. So now what I want to do is go down here and I want to say, one second, I got to think here. Animation.resolution X, except this is going to actually be X range. And this is going to be Y range. Okay. And then what I want to do is I want to say X range, Y range, plus X range over 2. Let's multiply it by 0.5 because I like multiplying by 0.5. It's a hobby of mine, multiplying things by 0.5. Don't ask me why. I just do it sometimes. You know, I'm like, hey, you there, can I multiply you by 0.5? And they're like, what does that even mean? And I'm like, you know what that means. Everyone knows what that means. You know, I want to multiply you by half. You know, divide you by 2. You know, if you know what I mean. I don't know anymore, guys. I should just quit. Okay, well that didn't do what I wanted to do. That's okay. That's okay. One second. X range divided by 2. Y range divided by 2, but that's not exactly what I want, is it? I want... Oh, I see what I want. Yeah, I see exactly what I want. So I want to do... How do I do this? I need to do... Let's do 0.1 times animation.resolution X times 0.5. So this is actually times 0.05. And that should be it. And we're going to do the same for Y. 0.05 times animation.resolution Y. Let's go over here and let's make that. Give it a second to do its drawing, and then we can actually attack the hard problem here, which is going to be that while loop. Oh my gosh, it's going to be a pain. Freaking pains. It's going to be fun. It's going to be fun. Okay, so let's see. Looks like all the points are being generated, and none of them are going over the edge. So let's increase the, I suppose, real quick. Let's increase the size of each of these dots. So let's do I-10 or something like that over here, and let's make that. Okay, so let's see what happens. We're going to give this guy a second to generate. And let me see. I want to time this once. Let's do Mirage here. Okay, so it looks fine. Yeah, looks good. And the red and green, that's pretty Christmassy themed, right? Yeah, this is good. This is good. This will be good. Okay, so what I'm going to do then, I'm going to drop this back down to 5 because I think 5 is a little bit more manageable for the simulation. So let's drop this down to 5. Okay, so now we have that generated. All the points are generated. So now we have a new animation current frame. So we're at a new current frame. Now, the question is, what is happening with this while loop? And that is a very good question. Okay, so let's just read this loop real quick before going into it. Let's just check to make sure that everything seems okay. So we're saying while the distance between the current hole and part of the hole is greater than the threshold, we know we enter the while loop every time. The threshold is arbitrarily set at 0.001. So in principle, we should have the distance between the current hole and the actual object point be the exact same. Now, here's where things get a little bit complicated. We say if I equals 0, okay, so we're at the very first iteration. We set the current hole to be the par.hole of 0, okay? That's fine. We do an I++ there at the bottom of the loop, so this should be okay. And what does that mean? That means that basically we set it equal to the leftmost point, okay? Now we say final angle is going to be 2 mpi, so that's as much as we could do for rotation. And we're going to say for j equals 0, j less than par.points.size. So we're going through all the other points in the simulation, and we're saying the angle temp is going to be the angle between the previous hole, which at this point is 0, 0, the current hole, which at this point is going to be the leftmost point, and par.points. And we say if angle temp is greater than final angle, oh, this should probably be less than. Rubber.code, my friend. Let's see what happens if we do this. Let's just go to make. Oh yeah, look at that. Look at that. Booyah. Yeah. No infinite loop. Woo! Fist bump. Oh yeah, never mind. You can't fist bump me. I get it. Yeah. It's not because, you know, we're talking through the internet. It's just because, yeah, I'm not the type of person you'd fist bump. I get that. My boss says the same thing. Yeah, I try to give him fist bump all the time, and he's like, no. And I'm like, you don't have to be mean about it. Like, you could just say, I don't want to touch you, and that's fine. I get that. Okay, so let's keep going from there. Oh man, there's like no one watching, I'm pretty sure, because like there's nothing in my chat. So I'm like, oh my gosh, I'm just screwing today big time, but that's okay. I'm having fun. If no one else is, that's good. Okay, so let's pop over here. What do we do? I don't know what I do. I don't know what I'm doing with my life right now. So if you guys have options, maybe job offers, I'd gladly take them, and we'll see how we go from there. Hey Edge, what is up? How are you? Thanks for coming in. Okay, so now what we need to do is animate this. It seems to run. That's nice. Let's go ahead and remove the C out. Actually, no, I want to go up here. I want to see. Oh, you. Oh, make, right here. 2, 3, 4, 9, 60. 12 steps. No still here? Hey, I care. Okay, so what are we gonna do? I want to do something. Janik. Okay, good. Look, guys, I'm sorry. The only way I can tell if people are here is if people say something in chat. And so it's just one of those things that I'm just like, I don't know. Is anyone here? I don't know. I have no idea. I guess I could have a laptop on the side that's monitoring how many people are watching. I'm so disappointed with my programmer colleagues. They are sometimes so defensive about some languages and act very aggressively, rejecting every idea about them without proper argumentation. You know, that's fair enough, you know? So, for me, I know 3 languages that I would say, okay. I know Fortran, C, or C++, and Julia. I know Python okay, I know MATLAB okay, but for the most part, these 3 languages, anything I need to do, I can do in these 3 languages, right? Yeah, right, so that's what I said. I could have like an extra laptop up, but I like the idea that you guys see everything that's on my computer screen. I don't like the idea that I have a second screen on the side that I do all the chat and stuff on. You know, I like the fact that you guys see exactly what I see. It's just, I don't know, it's a different way to do things. But yeah, so I find that when I'm switching between these 3 languages, it drives me nuts, you know, because like sometimes I try to use Fortran syntax in Julia or Julia syntax in C or even CUDA sometimes. I use CUDA syntax and I'm just like, what the heck? Why am I even thinking this should be vectorized? It's obviously not vectorized. Anyway, that's beside the point. The point is, you know, I really wish that there was one good language that just outperformed all the other languages. What? No way. No way. C. If they think C should be dead because it's so old, what do they think about Fortran? Holy crap, Fortran is still used. Like, it's one of the most regularly used. It is one of the most regularly used languages for computational physics, Fortran is. So, I never said you need a second computer screen. I said that ping the Twitch API. Have it. Oh, yeah, fair enough. Ed, you're totally right. I could have done that. But you're right. Like, I guess it depends on where you're from. So yeah, I hear very good things about Rust. It's a language that Gustorn keeps trying to tell me to get into, and I keep failing miserably. I'm like, I should try it, and I just don't. Along with Haskell. It's another language that I keep wanting to try, but I keep not trying. Oh, yeah, you're right, you're right. Dr. Kegel, you're right. I can do everything that I need for work in those 4 languages. That's what I mean. With those, I'm set. You know, they're tools that I wish. I wish there was a universal language, but that seems impossible currently. Yeah, it's so the issue that I'm finding is, how do I put this? The work that I do is dramatically different than the work that anyone else does, you know? Well, not anyone else. There are people who do the same thing I do, but it seems to me that a web programmer needs fundamentally different tools than a games programmer, who needs fundamentally different tools than a, I don't know, whatever else you want to do, you know? Like, the issue is that the way that you do the programming is just different, and the scenes are completely different. In web programming, for example, like, if you're using a language that's 4 years old, you're dead. Like, come on. Language is just advanced so quickly in web programming. It's basically like you have to know the basic tools and stuff like that. Yeah, Edge, Bash OS developer. I mean, that's the thing. There's so many things. Computational physicist, you still need Fortran. You know, like a whole bunch of things here. You know, lots and lots of different things. And the point is, every single time you enter a new field, you're going to have to learn a new tool. The nice thing about computational physics, the tool that the field that I'm in, basically it's all either Fortran or C. If you know Fortran or C, you're golden. And that's kind of one reason I like it. You don't have to mess around so much with, you know, nonsensical, like, you don't have to mess around too much with random languages, you know? You know what tools you need, you use these tools. And that's kind of nice, you know? And the reason is because Fortran and C are still as fast as you can get, you know? Nowadays, Julia is catching up with the Julia GPU stuff, you know, if the Julia GPU stuff matches. Oh, you know what? When I said web languages, I meant web frameworks, but that's okay. I like Bash because it's mostly I can read and figure out that man page. I like Bash because it's mostly can I read and figure out, oh yeah, fair enough. Man pages are awesome, by the way. I wanted to create a video game once called We Are Man, which was basically like, how do I put this? It was basically like, I don't know. It was named after man pages. And like you basically wrote your own manual for how to survive a post-apocalyptic world where you're an android, and you have to like help people figure out how to, you know, use spells and things like that, or not spells, but use like technology to their advantage. Okay, so let's go ahead and yeah, let's do this. So now we have to do the animate line function to just kind of draw some lines to different points. And let me think. Let's not do the animate line. Let's actually do draw line. So I'm going to go back into visualization and Cairo and Cairo visualization.h, and let's see, where's our draw line? I don't have it. Line. I have animate line, which I guess I can just give it no time and then we'll be set. Yeah, that's okay. Let's do animate line. It'll be okay. It'll be okay. So what I want to do is I just want to draw out the outer hull, just to make sure we are drawing a hull. Now, the fact that we go back to the initial point leads me to believe that we do, in fact, actually draw a hole on the outside of these objects. But just to be sure, let's just go ahead and check it. Because there's one more thing we're going to have to do, and it's going to be a little bit of a pain, but not so bad. I think we can get it done today. So par.hole pushback. So we have all the holes. And so now what I want to do is just at the end here, let's just draw it out. So let's do for int I equals, oh my gosh, what am I doing here? Size t, I equals 0. I less than whole, sorry, par.hole dot size. And then we're going to do I plus plus. And again, guys, and now what I want to do is I want to animate the lines between each of these guys. So what we're going to do is we're going to say animate line. And it's going to be between animation, int start frame. Oh, I have to give it a start frame. Oh, I was getting fancy with this one. So we're going to say start frame. And how about I make the start frame be this? So I'm going to go up here and I'm going to set animation.current frame. So I'm going to set this equal to something. So let's just call it int current frame is equal to animation.current frame. I know this is kind of a silly way to do it, but let's just go here and drawing outside hole. Okay, then we have animation, and let's just do the start frame as current frame plus I. Okay, so that's going to be the draw frame. Time, we're just going to set this equal to 0 for now. And then we need the 2 origins, which is going to be, I suppose, let's do this size -1. And then we're going to pop down here and we're going to say, yeah, let's just do -1 for now, just to make sure this works. And then we'll kind of work on it from here. So we're going to do -1, and then we're going to say, par.whole of I, and par.whole of I plus 1. And then what do I want? I want the color, which is going to be a color. So let's just read in color, and we're just going to make all the lines red. Why not? Red. Okay, so let's pop up here and let's create the color. So we're going to say color. Oh, hello. Color red is going to be equal to. Do I have an A? I think it's RGB-A. Screw it, let's see what happens if I make this. Look at that, it made! Yeah! To summarize the last 10 minutes of chat, if you want to have some chat activity, just talk about something slightly controversial. Oh, maybe. Let me go to Mirage. Scroll down. Here's all our points being generated, and they're all generated, and we're not seeing any lines. Crap. Where are our lines? Why do we not see any lines? There are no lines at all. Crap, crap, crap. Dang it. Let me just go ahead and move this over here for now, and let me shrink this down. Okay. What did I say that was controversial? Oh, I Love Twitch said something that was controversial. Animate line. Let me see how we've used animate line before. Actually, let's change this to a 0.1. Oh no, oh crap, I gotta freaking, that's fine. It ran last time, right? That's a good sign. Give it a second to draw all the images. We're drawing way too many images, by the way. Like, we could stop at 300, but for some reason I'm just letting it go to like 1200, because why not? So we have all the points, and we're still not drawing lines. Crap. Crap. Okay, so this means, what does this mean? I'm actually not sure. Animation, current frame plus I. So I guess what I want to do is I want to go up here to the top to main, and I don't want to draw the frames at the end. Let's just go ahead and not draw the frames. Let's go down to gift wrap. Animate line. This seems to be perfectly fine, doesn't it? Size t I equals 0. I less than par.whole.size. He's starting to sound like a programmer. Who is? Let me see. Animate line, animation current frame plus I, 0.1, par.whole, whole. Let me see. No idea. I have no idea what's happening here, guys. So let me see. What do I want to do? I want to check to see the last time I did an animate line. So let me go back into viral video. I'm sure I did an animate line here, right? So viral video, and then viral video.cpp. Let's look for animate line. And let me see. Animate human. That's fine. Viewers. Viewers. Line. Okay. Layers 0. Current frame. Layer 0 current frame. 1. Yeah, I mean, I'm not cursing. Did I curse? I hope I didn't. I apologize if I did. Positions I and positions of 0, white. Okay, so maybe the color is wrong? Yeah, maybe I initialized the color is wrong. Let me look for a white. Yep, that's white. White. 1, 1, 1, 1. Oh, that's why. The alpha is 0. Let's do R. Let's change this to R1. Okay, so now what I want to do is write and quit. Go up here to the top. Down to draw frames, and let's go ahead and remove down here. Make. Okay, now let's see what happens. Cursing means more statement of fact. That means ready. Oh, yeah. Well, it's fine. I say crap a lot. Comes back from homestarrunner.com. Oh no, there are the lines. They're right up there. Do you see them? Oh, I bet you don't see them. Oh, shoot. They're up there. Why are they all at 0? Darn. Okay, so on the one hand, something's happening. On the other hand, it's not what we want to happen, but that's perfectly okay. So let's see, what do I want to do here? I want to go back a second. So vi.visualization, Cairo visualization.h, and I want to change the number of frames to 400 because we're rendering too many frames. Okay, so we've done that. Now let's pop down here. And what do I want to do? We're animating on the lines. That seems fine. But what happens if we change this to a 1? Actually, let me do this. Let me do stdc out. And I want to just output par.whole of i.x and new tab and par.whole. 1 second. Whole of i.y. New tab. Let's go here to make. Okay. And let's see, what do we have here? We have 0.2. Oh, I see the problem. I totally see the problem. I know why it's all around 1. That's because I have not scaled the x and y. Got it. Okay. So what we need to do then is we need to go up here and let's create 2 additional points. So we're going to create vector, and it's going to be A and B, because screw it. And let's go in here and let's do it. So we're going to say A dot x is going to be equal to basically the same thing we have up here. So let me pop up here and let's see if we got that. So a dot x is going to be equal to par.points of I. Yep, so this guy. Yep, that guy. Except in this case, instead of par.points, it's going to be par.whole. So where are we? A dot x. So it changes to par.whole of I dot x. And we're going to do the same thing for y. So we're just going to yank this, YYP. And guys, I'm doing my best every time I do something kind of tricky with VI to mention what I'm doing that is tricky. So like, for example, right now I'm pressing dot. But what I did is I pressed R and then Y, which replaces one individual character with Y. And so that's what I did there. So here I'm going to do yank to yank, so Y to Y. And I'm going to paste it down here. And basically I'm going to change these to B. So RB, RB. And then I go down here and I add a +1 by pressing A +1, and then I put a dot here. So I do my best to kind of vocalize what it is that I'm doing. What are you generating thousands of images instead of SVGs or GIFs? The reason I'm just generating thousands of images here, or is simply because I could convert it all into a GIF, but in the end, there's something that I really like about the video or the visualizer that I have now. So let me go ahead and run the make real quick, and I'll show you what I mean. So we run make, we generate our 400 images, and if I run the last Mirage, what I can do is I can scroll in and out of these images. So if I scroll down, I can get to each of these frames individually, so it makes it a little bit easier for me to work with. Now, unfortunately, I screwed this one up because I forgot to put A and B, and instead I left it as par.whole. So let me change this to A and B. And hopefully, this will solve one of my issues. So let's pop over here. And let's try it one more time. So yeah, I just like generating the images because it's easier to do for me. Now, I can obviously put them all into a GIF, no problem. But this is kind of how I wanted to do it. And come on, draw some lines, babe. Boom! Boom! Look at that! Yeah! Woo! Yeah, got ourselves a convex hull. Do you see that? Oh yeah, that's so cool. Oh yeah. Okay, let's change the wrapping paper to like blue or something like that. I like blue wrapping paper. So let's change it to blue. Let's do R0 there, and let's change this to blue RGB. So let's change this to a 1. Let's do a make. And then I want to convert them all into a GIF, just so that we can say we have it. So let me do a Mirage temp, scroll down. We have all the images all the points being generated, and blue circle. Now, one thing that's weird is it's going the opposite direction from what I intended for it to go. That's a little bit weird. And the lines are being animated. Okay, so there's a couple bugs here. A couple bugs. One, it's going the wrong way. And I know why. I know why it's going the wrong way. It's going the wrong way because... How do I put this? When I count from 0 to 100, in Y, I typically count upwards. But this guy, when it counts from 0 to 100 in Y, it counts downward. So that's one bug we need to fix. And the other bug we need to fix is the fact that lines are starting to be drawn before other lines finish. So we should probably figure that one out. That one shouldn't be so hard. So let me think. We have current frame plus I. So how long are we giving it to draw? We're giving it 0.1 seconds, which is the equivalent of... let's give it a little bit more time. So let me think here. How about we give it, instead of current frame plus I, we give it current frame. Let me go up here and let's create a draw time. So double draw time. We're going to set this equal to 0.1. And we're going to say this guy plus I times... Hey, Slayer Darth, what's up, man? Okay, so we're going to do I times... And it's going to be draw time. Wait, I got to think here. Should be draw time divided by animation.fps. Right? It's going to make. Let's see what happens. Give this another time to do its thing. Then we're going to open up the last Mirage. Scroll down. We have all the points being generated and... Okay, so that I just screwed that one up. Yeah, that they're all being generated at the same time now. I mean, we're still generating the convex hull, right? Yes. Feel free. There are no stupid... Okay, everyone says there are no stupid questions. Let me put it this way. There are very few stupid questions. Covering my bases, okay? I've gotten some pretty stupid questions from Frank. I feel bad. Maybe I should... One of my colleagues has a repo for all the shell script provisioners he runs and set up a virtual instances of Ubuntu boxes. Okay. Sure. Okay, so let me see. Animate line, current frame plus I, current frame plus I times draw time over animation.fps. Okay, let me think here. Frames per second. Good. Draw time is going to be in seconds. Do not name color constants with their color name red, because you can change the color value, but not the name. Yeah, that's true. Yeah, fair enough. I just realized that. Let's say, wrapping color. I normally do that. I just, for some reason, this time didn't. Okay. Oh. Okay, so what do we do here? Animate line. I thought this would be right. Let me think real quick. Frames per second. Okay. We want a number of frames for every draw. Right? So let's see. If we have frames per second, draw time is 0.1. Oh, but maybe this is going to be... Maybe it's going to be 0. That's probably it. Let's remake. Dr. Kegel works for me. Mirage, let's scroll down. Come on, babe. Okay. No, it's still broken. See that? See how it's broken? Yeah, that's totally broken. Dang it. Why is it doing this? Let me just do this then. Let me multiply this by like 4 or something. Let's do Mirage. Animate line starting at that frame. Yeah, this should work. Make. So we get 4 frames to draw every point. Mirage, scroll down. Okay, so that time it worked. Okay, so this seems to be okay then. We are drawing the convex hull. Okay, that one works. So let's go ahead and do the harder one to fix, which is going to be flipping all the y values. Okay, so what do I need to do here? Origin.y is not going to be part.points.y. It's going to be... let me think here. So it's going to be part.points.y. So what we need to do is we need to flip. Can I push dodgy commits to your repos? I mean, you can send pull requests, and I will totally look at the pull requests. Just a simple, hey, I made some changes you may like, but you've got no license, so I figured I'd see if you were interested in them. Wait, talk to him about it. Where's... Oh, I see. Yep, yeah. Okay, so what do we want? We want something that will flip all of the y values. Okay, and this is going to be a little bit of a pain, so let me draw this out, just so you guys can figure out the problem here. Okay, so right now, when I count up, when I count to y, what I do is I say x is here and y, or sorry, x is in this direction and y is in this direction. However, Cairo reads it the other way, reads y in this dimension, right? So when I draw a y, when I draw all the points for y, what ends up happening is all the y points are flipped about this axis here, which is y equals 0.5 times animation dot resolution y. Okay. So now the question is, how do we flip them back? Let me think. So what I need to do is every single point, I guess we can find the distance. Okay, so let's say we have a point here, which I'll put in green, I guess. Okay, so we can find this distance here. And then we can add that distance twice, that distance to it. So we find that distance and then we add twice the distance. Yeah, I guess that would do it, but I feel like there has to be a better way to do this. What's another way we can flip all the y's? Let's see, so if we read up... Oh, maybe if I do this. Maybe if I turn all the y's negative. Okay, so I turn all the y's negative. Okay, so I multiply by -1, and then I give it an offset. Yeah, let's try that. This should work. Yeah. Oh, this is gonna be awesome. It's like the worst idea ever. Okay, so we're gonna say part of points at y. Okay, let me think. Times y range. Okay, so this is gonna give it values there, but what I actually want is the following. So I want to say 1 minus part of points dot y. There. And let's pop down here and do the same there. So I guess it's gonna be 1 minus. This is either a good idea or a bad idea. Just like all ideas. Let's see 1 minus again. And let's see what happens. Let's do make. Yep. Make. Okay, give it a second to do this thing, and let's see what happens. Scroll down. It looks like points are being generated, and come on, draw lines in the right direction. Woo! Lines are being drawn in the right direction. We got this, guys. Okay, so now I have to do one more thing. What do I need to do? That is a very good question. What I need to do is I now need to draw individual lines up here. So what I want to say is, let's create a new color up here before this while loop. And say, color, temp, line, let's say line color. And it's going to be equal to white. So we're going to say 1, 1, 1, 1. Okay. That's good. Let's see, code style, extract the point animation, position, conversion into its own method. So you only have to change it at one place. 1 second. Extract the point animation to position conversion into its own method. So you only have to change it at one place. Yeah, I could do that. That's fine. I just haven't yet. Good. So we can add that in a bit. But let me go ahead and get this done, and then we'll kind of worry about that in a second. So now we have the white color. What I want to do now is change the place that we are basically drawing all these different lines. So in this for loop right here, what I want to do is I want to... Oh, how about this? I do line color. And then I do whole color. And whole color is going to be the wrap color. So actually, let's just grab the wrap color and let's put it up here. Okay? And what I'm going to do is I'm just going to go ahead and comment this guy out here so that we draw the whole while drawing everything else. So where's A and B? A is going to be par.whole x. So I think A is always going to be the same. So let's go ahead and go up here. We have A. I got to think here. Yeah, so this should work still. So let's go down here. And let's say A is going to be these guys again. Okay. So we have that for A. Now, we have to think real quick. Or I have to think real quick. We're going to need two different guys. We're going to need... Okay, what do I want here? We're going to have to go through all these different points. So, let me just kind of draw something in here. And what I'm going to say is B is going to be equal to these guys in here. Sorry about this, I'm a little bit scattered right now, but this should still work, I think. So let me pop up here. And then we're going to... Am I off a point? I am. Okay, b.x is par.whole. Except I don't want it to be whole in this case. I want it to be par.points of j. There we go, that's what I want. Par.points. Okay, so now what I'm going to do is I'm going to pop down here. And I am going to animate... Yes, this is what I'm going to do. I'm going to animate the line here. Okay. And we have A and B, except in this case, instead of current frame, I'm going to do animation.currentFrame. And then I'm just going to pop down here. I'm going to say animation.currentFrame. Current frame. Plus plus. Okay. So now I'm just going to run this, see what happens, just to make sure it does run. Let's do make. Of course it doesn't. A was not declared in the scope. This is because I did not define A and B. But in fact, I'm going to actually have to define A, B, and C. So let's do vec. A, B, and C. And I'm going through this kind of quickly because I kind of want to get this done today. C is not used. I know C is not used. Don't tell me that. And now let's do Mirage. Yep. Scroll down. We have all the points being generated at the start. And I need to get rid of those lines. Yep. Yeah, I need to get rid of those lines, definitely. Yep. 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 Okay, that's good to know. So how am I going to get rid of the lines? Well, let's think about this one. So what I could do is I could read in multiple different layers. This is about to get kind of confusing. So what I want to do then is I want to pop down here. I want to give these guys 0 times to draw. And I want to give this line color, just so we can go ahead and fix those bugs as we're here. So we're going to change this to line color. I just wanted to visualize the drawing of the angle to each point. Okay. So do the line color. That's okay. And that's going to draw a line to it. I guess what I should do... How do I erase the line afterwards? I mean, I can always just... Okay, maybe I can change the context back. Yeah, let's try that one. So let's go up here and let's define the first frame. So we're going to go here and we're going to say first frame. Oh, I'm sorry. I can get more music. It's just, I don't know. I like the music that I have, so I kind of like play it. I also don't really listen to music that much, so it's one of those things that like, I just kind of keep going. What I do is I kind of go to Josh Woodward. So let's go here and let's do Josh Woodward. And I kind of look for songs that he has. And what I do is I take the songs and then I speed them up by 1.5. And that's what I do. So let's do first frame and let's go int first frame. It's going to be equal to, 1 second, animation.currentFrame. Okay. And so what I want to do then is I want to pop down here. And I'm going to say animation.currentFrame plus plus. And then what I want to say is animation.frame context. of animation.currentFrame. And I want to set this equal to animation.frameContext of first frame. So let's do make. Let's see what happens. Make file segmentation fault. Dang it. Yeah, I figured this would be an issue. So let's go ahead and do GDB and a.out. Run. And you are doing something, babe. Yep. Not really sure what you're doing, but you are doing something. Control C, Control D. Yes. Remove this line. Make. And give it a second to do the thing. GDB, no, Mirage. We're drawing all the lines, drawing all the lines, drawing all the, yeah, that's what I figured we were doing. We need to remove those lines. So this guy gave us a segmentation fault. Animation frame context, animation current frame. Okay. Is going to be equal to animation frame context of the first frame. I just wanted to clear the context. That's all I wanted to do. I wanted to set it back to an initial point. But I guess maybe I'm not allowed to do this. So let me just go ahead into the make file. And let's not run Jarvis at the end here. So let's make. Make. And now let's run GDB and a.out. See if this is an easy fix. Run that. Oh. Well, I'm not really sure what's happening here. But I think I actually, wait, I think I do know. What I want to do is not run this, but run GDB and Jarvis. Now let's run that. Okay, and it should give us a seg fault here. Now let's do a backtrace. Let's see what the backtrace is. It is Jarvis 35. Oh, that is gift wrap. 111. Yeah, I figured it was that one. There wasn't really much of a hope there. Okay, so what we need to do then is we need to create different layers, and we need to constantly clear the layer that has the lines on it. That's what we need to do. So let me go ahead and go here, and let's. What do I want to do? I want to comment this guy out. Animation current frame plus plus. So I'm going to do animate line. Then what I want to do is, instead of using anim, what I want to do is I want to go in here and let's read in frame layers. So this is going to be a vector of frames. SCD, vector, one second, frame. And it's going to be layers. Okay, so let's go over here and let's see. Is this the only thing we needed in? Control D, yes. Let me read in gift wrap. No, Jarvis. .h. Oh my gosh, if I can type. So we're going to go in Jarvis.h. And what I want to go down here and let's change this to a vector of frames. Anim. So SCD, vector of frames, anim. All right, we're getting there, guys. So what do I want to do then? When I initialize these guys, what I need to do is initialize them as a vector of frames, and then I need to go through and change everything. So frame anim, instead this is going to be a vector of frame, and it's going to be layers. And now what I want to do is basically change all of the anims to layer of 0. So let's go ahead and change all these guys up. So I'm just going to search for anim, and we're going to change this to layer of 0. Change this from the layer of 0. Oh, actually, in fact, we should probably also initialize layer of 0. Let's do layer of I. And let's pop up here and let's say 4. Size T. 1 second. I equals 0. I less than layers dot size. And then we're going to do I plus plus. Pop this down here. There. And let's go ahead and create all these layers. I suppose this create background should also be in there. Oh, maybe it should only be in for layer 1 actually. Yeah, let's make it only for layer 1. Layer 0, sorry. Yeah, so let's go ahead and remove this. And now let's say layer of eye here. Okay, and layer of eye here. Okay, so now what we need to do is instead of draw frames, draw layers. I think that's one. Let me go back and see what we have here. VI, visualization. I don't know. What am I looking for? I'm looking for Cairo. And then Cairo viz.h. And let's do layer. Draw layers. Fantastic. Okay, so we're going to draw layers and read in layers. Oh. Layers. Go up here, read in layers. Okay. So we have everything set. I think layer of eye in it. Yeah, okay. This seems perfectly fine to me. So now what I want to do, I want to go down here to gift wrap, and now we have to change everything up. So let's look for anim again. Anim here is going to change to layer of 0. Again, it's going to change down here. Of 0. Next. Layer of 0. I should just do a search and replace, shouldn't I? Yeah, let's just do a search and replace. So we're going to do S, anim, and layer of 0. Hopefully this will do it. And let's do CG. Anim, yes, I want to replace that one. Yes, I want to replace that one. And that one, yep. Yeah, you're doing good at finding these guys, yep. Yep. Yeah, let's just replace that one too, yep, looks good. No, do not want to replace that one. Yes. 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 Sure, why not? Sure, why not? Sure. It's all commented in anyway. Yes. 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 No. Yes. Okay. So that seemed to do something. Good. Let me just see if this actually runs now. Make. It doesn't run. That's okay. That's because I accidentally called all the layers of 0 layer without an S. That's okay. So let me change all the layer of zeros to layers of 0. So let's do S layer to, let's do a 0 to layers of, 1 second, something like this, I think. Should do it. Good. And let's do CG. Yes, 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 yes. Yeah, it should be all these guys. I could have just done G. Should have just done G, but that's okay. Now let's go make. Okay, frame layers was not declared in the scope. Fair enough. So let's see what do we have here. Let's go up to 19. Let's try this. Make. Okay, vector. Oh, I need an SCD. Bet you don't hear that very often. Okay. Create layer was not declared in the scope. This is because 21. These should all be S's. Make. Okay, hopefully, let's run a ./Jarvis. Hopefully we don't get that. Dang it, freaking. Okay, so let's run GDB. And let's run, oh, sorry about that. Control D. GDB Jarvis. And now let's run that. Let's do a, oh, it's on create background. Create background. Let's run a backtrace. 25. Create background. What? Why would it be in create background? Let me do a control D. Yes. Let me go back into the previous directory. Where did we have something that required multiple layers? This would be in surely the Huffman coding. So let's do Huffman. Yep. And Huffman visualization. .cpp. Let's see, do we have a layer? To draw layers, yep, fair enough. Layer.size, layer init, layer create frame, create background, layer 000. Seems to be fine. Create frame, 600, 400. current frame equals 1. Okay. Not seeing where the issue is here. But maybe there's something wrong with the create background function. So let me see. Create background. Layer of 0 should be... We should have a layers of 0. Let me see. Do we get any further information with this? It just says backtrace quit at... It just quit. So let's go into VI. And let's see if we can figure this out. Visualization. And let's do Cairo.cpp. And let's go to create background. Frame animation. Okay, this should be okay. Yeah, we're reading in the first guy. So Cairo set source RGB, frame context. Did I have to do something special that I didn't remember? Layers of 0, create background. Huh. Cairo fill. Yeah, this should still be fine. Quit. Have a visualization, and let's do create background. Did I have it defined in here? Oh, sorry. Create background. Create background. Okay. Is this any different than what I had before? Let's go over here and let's check it out. So let me go into VI, visualization, Cairo visualization.cpp. And let's do create background. Okay. This looks exactly the same. I'm not seeing an issue. But it seems to work over there, but it doesn't seem to work over here. Frame animation RGB, set source RGB, frame context I, double RGB. It is the same function. Cairo fill, frame context I. Okay, so what am I doing wrong then? Let's take a look at this guy over here. Scroll up here and let me see. Are they doing the layers differently? Vector of frame layers. Oh, you know what? I know what I did. I totally know what I did. Make Jarvis. Let's go ahead and remove all of the PNGs in temp. And let's draw on it one more time. Okay, so it should be generating all the images now. I didn't have it outputted in draw layers, but maybe I should have. So now let's go into the last mirage. Okay, so we have all of these guys being generated and all the points are being drawn. Fantastic. Okay, so now let's go ahead and clear the context. And this shouldn't be so bad, I think. So what we're gonna do is we're gonna pop down here and I want to draw animate line, layers R1. Okay, layers R1. Oh, also I need to do one more thing real quick. So in first frame is layers 0 of current frame. However, what I need to do is up here. Okay, this is gonna be a little bit complicated, but it should still be okay. So let's see. First we need to draw random distribution of points. Fair enough. So we have grow circle, and what I want to do up here is I want to say layers of 1. Dot current frame is going to be equal to layers of 0 dot current frame. Okay. This should do that. Now we're going to go down here and we're going to call these layers of 1. R1. And basically all these times we see layers of 0, except for up there. I think that's still fine. Let's go and change this to layers of 1. So this is going to be another R. And let me see. Oh, R1. So layers of 1. So let's change this again to a 1. Okay, so now we have everything being drawn. Let me just make sure this still works because we're drawing it on line 1 or layer 1. And then after that, go into the make file. Ooh, we're so close. We can get this done, guys. We have 10 minutes. We can get this done. Let's go to make. Where's the last make? Let's let that run. And while it's running, let me go down here and let me just make sure that everything's doing what it needs to do. Good. Okay, so now let's go here to Mirage. Scroll down, everything's being drawn. Fantastic. Okay, we're drawing on layer 1. So now, how do we clear context in Cairo? That's a good question. 1 second. How How do I clear a surface? How do I clear a surface content? I want to clear a context. Cairo paint, Cairo destroy. Probably don't want to destroy it. Cairo set source RGB. Cairo set source RGB. Cairo paint. Let me see. How do I clear a surface? Maybe I should have looked this one up beforehand. Set source RGB. Oh, okay. So what I want to do, set translucent color, RGBA, set operator. This it? Cairo paint. Cairo set source RGBA. Oh, okay. So let's grab this guy and let's create a new function real quick. So I'm going to go into VI, visualization, Cairo visualization as CPP, and I want to create a new guy, which is going to be, should I have it in frame? No, let's go down here and let's do function to clear a context. Let's go down here and let's do void clear context. And we're going to have to read in a context. So this is going to be, what is a context? Context. I think it's Cairo T. Let's check to make sure. Visualization. Cairo visualization.h. Let's see, what do we have for context? It's going to be Cairo T. Cairo T star context. Okay. Pop down here and let's, okay, there we go, we have it. Just because I hate these types of comments, let's just remove that there and remove this here. Okay, good. So Cairo set source RGB. And what I want to do is set them all to 0. So RGBA, in this case, I want to set them to, I suppose, no, this is okay. R0, 0, 0, 0. And then at the end here, we're going to do Cairo set operator of the particular context. So we're going to do context, and it's going to be Cairo operator and over, I think is what it is. Okay, so what I want to do now is I want to change this to a CTX because I like that notation better, and screw the rules. I can do whatever I want with my life. Okay, CTX up here. Okay, clear context. That should be it here. Okay. There we go. So that should be it. So now what I want to do is go over here, and I want to basically take this function and put it into our header file. G. Let's just grab both these guys. I'm kind of stretched for time right now. So let's go here, there, write this, right quit, right quit, right quit, jarvis.cpp, and now we're just going to clear the context, and we're going to see what happens. So what do we have here? Where are we? We're in gift wrap. We have this guy, and before doing animation current frame plus plus, I want to, here it is, do the following. I'm going to do clear context of, and it's going to be layers of 1. Yep, layers of 1. Dot frame context of layers of 1 dot animation, oh, dot current frame. Seems to be doing something. Segmentation fault, dagnabbit. Okay, so let's do GDB. GDB, and I want to do GDB of Jarvis. Now we're going to do, oh, Control D, VI makefile. Go down here, let's not run this. Now let's run make one more time. Now we're going to run GDB of Jarvis. Yep, and we're going to run that. And now we're going to wait for it to segfault. And now let's do a backtrace. And it says it is breaking a visualization Cairo visualization at CPP of 354. Okay, so it says 112. Let's pop here. Okay, good. So we have 112. That's where I figured it would break. But then the other guy is breaking. It's Cairo set source RGBA. Oh, why is it breaking there? Well, dagnabbit. Let me see something. Gift wrap layers par at Jarvis CPP 112. Clear context. Context equals some sort of, yeah, that's fine. A visualization Cairo visualization CPP. Cairo set source RGBA. That's where it's breaking. Cairo set source RGBA. Why would it break there? Huh. I have no idea. Cairo set source RGBA. Why is it breaking there? User lib Cairo. I mean, we should just be setting the color. Are we setting the color twice, maybe? Let's see, when are we outputting stuff? We're outputting stuff at the end of every one of these loops, so it looks like we're actually getting somewhere. So let me see, clear context, layers 1 frame, context layers 1 current frame. Well, I'm actually not sure why this is happening. Layers 1 frame context, layers 1 current frame. Let's go to the clear context function and see if we can figure something out. VI, visualization, Cairo visualization.cpp. And let's go to the clear context. Here it is. Okay. See, it doesn't seem like anything could be wrong here. We're setting it equal to 0, 0, 0, 0. We're reading in the context. Everything seems okay. Maybe we're doubling up on something? Why would we segfault on Cairo set source RGBA? Maybe... Just gonna see if anyone Cairo set source. No, let me see if there's a better way to clear the context. Let me see. Cairo create. Maybe I should just destroy and reinitialize it? How do I clear a surface? Let me see. Cairo save. Of course, you don't want to forget the default Cairo operator over again when you're finished. The most convenient habit, Cairo save, Cairo set source, Cairo paint, Cairo restore. Did I forget to Cairo paint? Let me just pop down here, and let's just read in exactly what they have here, except changing the CRs. Yeah, let's see what happens. Okay, let's read this in. Okay, we're gonna change all the CRs, so let's do this. I want to do this, S, and let's do CR, CTX, CG. Nope. 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 This is why I don't like CR. Yes. 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 Okay. Screwed up on that one, but that's okay. Control D. Yes. Okay, so now we've changed this to this. And of course I need to change this to, instead of RGBA, it needs to be all zeros. Let's do make. Run Jarvis. It still gets the segfault. Let's go into GDB again. Let's run that. Run the last backtrace. and it is going to be in clear context. Kairos save actually is where it is. Okay, well this is something we're gonna have to fix a little bit later. So I'm not exactly sure what the issue is here, but it's not like in all these tricks we're playing with all the contexts. So this is something we're gonna have to fix, but I think we'll leave it for tomorrow to fix it. So tomorrow what we're gonna do is go ahead and fix this up. I might do it tonight actually, and then we'll start working on the next algorithm, which is, what is it called again? It is the greatest, one second. Oh, the ultimate planar convex hull algorithm. I'm kind of looking forward to this one because it's the ultimate planar convex hull algorithm. How could you not be excited for it? And then we'll kind of go from there. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys next time for the next episode of Simuleos when we finish up the visualization of the gift wrapping algorithm, hopefully fixing that seg fault. And then we go from there. Basically, we just have to find a way to clear the context, and then we can go from there. Anyway, guys, thanks again for coming in, and I will see you next time. Bye, guys.